In our last example of this section, we're going to look at a similar problem that we did last time. We're going to find y prime in the equations of the tangent lines to the graph of y minus xy squared plus x squared plus 1 is equal to 0 at the points where x is equal to 1. So we'll start by finding our derivative first here. One thing I want to be very careful of here is here I've got xy squared. I've got a power of x times a power of y. I'm going to have to use the product rule there. But we also have this negative sign in front of that. That negative sign is going to have to distribute to both terms of my product rule. So I want to point that out really quickly. We're going to have to be really careful with that term in particular. So I'm going to, let's copy the problem down first. Y minus xy squared plus x squared plus 1 equals 0. I start by taking the derivative of both sides of my equation. So the first term shouldn't give us any problem. We should have 1 times y prime minus. Now I want to distribute this negative sign to both terms of my product rule. So I'm going to open up a set of parentheses here. Minus, if we think about what our product rule says, it says f prime. So first of all, the derivative of x, that's just going to be 1. Times g times y squared, so this is going to be times y squared, plus f, so this time f, that's just going to be x, times g prime, the derivative of y squared. Here we're going to have to use our chain rule like we have been all along. That's going to be 2y times y prime. So we'll distribute that minus sign in just a minute, but I'm going to close my parentheses now because we're done with our product rule. And then I'm going to continue on. So the derivative of x squared is 2x, 1 is a constant, so its derivative is 0, and then the derivative of the right-hand side is also 0. So I'm going to clean up that left-hand side first. I'll have y prime minus, first I'll have 1 times y squared, that's just going to be y squared. I'm taking this minus sign and distributing that to my second term as well, so that's going to be minus. I'm going to reorder my terms here. I'm just going to rewrite this as 2xy times y prime. All I did was switch the 2 and the x. But then I can keep going, plus 2x is equal to 0. So now I've got my derivative. I've simplified it as much as I can. I'm going to keep the two terms that have a y prime. Let's keep those on the left-hand side, and then I'm going to move the other two terms over to the right-hand side. So let's see. That's going to look like then y prime minus 2xy y prime equals, let's see, that'll be positive y squared minus 2x. Now I can factor out a y prime from that left-hand side of the equation, and then that'll leave us with 1 minus 2xy is equal to y squared minus 2x, and then we can finally just go ahead and divide. So y prime is equal to y squared minus 2x divided by 1 minus 2xy. Whew. So there's our derivative. That was a fair bit harder than it was last time. There's the first part of our answer. The second part, we wanted the equations of the tangent lines where x is equal to 1. So what do I need for a tangent line? I need an x value, I need a y value, and I need a slope. Now if I look ahead to my slope, my derivative tells us the slope of the tangent line. We're going to need both our x value and our y value. So here in this problem, we're going to have to find y first. And for that, I'm looking at my original equation. So let's do this here. I'm going to do that in blue kind of to the right over here. I've got y minus, so I'm going to take the x value, which was x equals 1, and plug that in. So y minus 1 times y squared plus 1 squared plus 1 is equal to 0. So if I clean this up and do a little bit of simplifying, we'll have y minus y squared plus 1 equals 0. Let's see, that'll give us negative y squared plus y plus 2 is equal to 0. So I end up with a quadratic equation in terms of y. I don't really like this first term to be negative, so I'm going to move everything over to that right-hand side. You could also multiply the left-hand side by negative 1, but I'll just move everything over. That'll be y squared minus y minus 2. And now I can factor that right-hand side. So let's see. Two numbers that multiply to be negative 2, add to be negative 1. That should be y minus 2 times y plus 1, all equal to 0. So that means 0 is equal to y minus 2, which means one of my y values is 2. The other one, 0 equals y plus 1, means y must be negative 1. So I've got two different y values here, 2 and negative 1. Both of them, though, we said our x value was 1. So just like we did last time, we're going to end up with two separate equations of our tangent line. So let's scroll down just a little bit. First of all, I'm going to have the point, let's start with 1, 2. So I'm going to take that, and first of all, I need to find my slope, which means I need to plug that into y prime. So y prime is y squared, that's 2 squared, minus 2 times 1, all over 1 minus 2x, that's 1, times y is 2. So let's see, here I've got 4 minus 2, all over 1 minus 4. Looks like this is going to simplify to be 2 over negative 3, or negative 2/3. Remember, this is the slope of my tangent line. So at this point, I should have everything I need to write the equation of this line. Y minus my y coordinate is 2 equals m, that's negative 2/3, times x minus my x coordinate is 1. We'll distribute on the right-hand side, so y minus 2 equals negative 2/3 x plus 2/3, and then add 2 to the right-hand side. So y minus 2 equals negative 2/3 x plus, that would be 6 over 3, so 6 plus 2 would give me 8 over 3. And actually, whoops, I forgot to add 2 on that left-hand side. It should just be y equals there. So I've got y equals negative 2 over 3x plus 8 over 3 for my first tangent line. But that's only half the story. I have another tangent line. We used the y value of 2. Notice that the x value isn't changing. The x value is still going to be 1, but this time around my y value is going to be negative 1. So again, we're working with the same derivative that we found. This y prime equals y squared minus 2x all over 1 minus 2xy. So y prime equals y squared, that's negative 1 squared, minus 2 times 1, all over 1 minus 2 times 1 times negative 1. So let's see, this time around I'll have 1 minus 2 all over 1 plus 2. This time around, let's see, I should have negative 1 over positive 3, or negative 1/3. That's my slope this time. And again, at this point, I've got everything I need. Just to remember, we were working with the ordered pair 1, negative 1. So if we write the equation of our tangent line, we've got y minus our y coordinate is negative 1 equals m, that's negative 1/3, times x minus my x coordinate of 1. So that left-hand side is really y plus 1 equals negative 1/3 x plus 1/3. And then subtract 1, I should have y equals negative 1 over 3x minus 2 over 3. And there is the second equation of the tangent line. So please be careful. Some of these problems do end up getting a little bit lengthy here. We need to, first of all, keep an eye out for any instances in which we might need to use the product rule like we did up here. But then also, again, any instances in which we end up with two y values, because, again, that will mean that we end up with two separate equations of two separate tangent lines.